Every single day, the world consumes around 500,000 tons of sugar. It's that invisible ingredient that sweetens our coffee, powers our afternoons, and makes our celebrations, well, celebratory. But behind that simple sweetness is a colossal industrial operation, a world of incredible scale and mechanical power hidden almost entirely from view. The global sugar industry is a multi-billion-dollar empire built on a single, humble plant. So how exactly does a stalk of sugarcane, grown in a vast, sun-drenched field, start its journey to become the pure, white crystals you scoop into your morning brew? Well, the answer is a fascinating story of brute force meeting delicate chemistry, of raw nature and cutting-edge tech. In the next few minutes, we're taking you deep inside one of the titans of this industry, a mega factory that chews through millions of tons of sugarcane every year. You'll see the entire incredible process, from a green stalk standing tall to the final, gleaming crystal ready for the world. This is the unseen epic of sugar production, a transformation of unbelievable scale. And it all begins, not in the factory, but miles away, in the immense, sprawling fields where the journey really kicks off. Chapter 1. The Source. Fields of green gold. Long before the first gear turns in the factory, a kind of biological miracle is quietly unfolding across thousands of acres. This is the kingdom of sugarcane, a species of tall, perennial grass that's basically nature's own sugar factory. For 16 to 24 months, these plants stand in the fields, soaking up sunlight, water, and nutrients. Through the elegant process of photosynthesis, they convert solar energy into sucrose, the very molecule we can't get enough of. This sucrose isn't stored in a fruit or a root, but right inside the plant's tough stalk, a fibrous, segmented column that can grow up to 3 meters tall. The stalk becomes a living vault, a reservoir of liquid energy just waiting to be unlocked. The moment that cane reaches peak maturity, a race against time begins. The sugar content is at its absolute max, but from the second it's harvested, that precious sucrose starts to degrade. This kicks off one of the most technologically advanced and time-sensitive harvesting operations in all of agriculture. The old days of hand cutting with machetes are long gone, replaced by a fleet of mechanical behemoths. These are multi-purpose harvesters, towering machines that move through the cane fields like they're on a mission. At the front, a pair of rotating torpedo-like dividers lifts the cane and guides it toward a set of razor-sharp rotating blades. These base cutters slice through the thick stalks just above the root, preserving the plant so it can grow back for several more seasons. Once cut, the entire stalk is pulled into the belly of the machine. In an instant, it's chopped into smaller, more manageable pieces known as billets, each around 30 centimeters long. At the same time, a powerful extractor fan system blows away the unwanted leaves and other foliage, which are either returned to the field as natural mulch or collected for other uses. A single one of these harvesters is a marvel of efficiency, capable of clearing up to 60,000 square meters in a single day, a task that would take hundreds of workers to even attempt. As the harvester carves its path, a transport vehicle, often a large tractor pulling multiple bins, drives right alongside it. An articulated conveyor arm on the harvester transfers the freshly cut billets into the transport, so the process never has to stop. When the truck is full, carrying a staggering load of around 23,000 kilograms, its own critical mission begins. The clock is ticking. Every minute that passes, natural enzymes and bacteria start breaking down the sucroses. To get the highest possible sugar yield, the cane has to get from the field to the factory for processing in under 16 hours. That tight window dictates the entire logistical ballet of the operation, a continuous 24/7 stream of trucks moving from countless fields toward a single hungry destination: the mega factory. Chapter 2. Arrival at the mega factory. The factory gate is a scene of constant motion, a seemingly endless convoy of trucks, all loaded down with sugarcane billets, arrives from the surrounding region, forming a queue to feed the relentless appetite of the mill. These factories are true industrial giants. Some facilities are responsible for processing millions of tons of cane every single year. As each truck pulls into the unloading station, the sheer scale of the operation becomes breathtakingly clear. In many modern factories, the unloading process is a seriously impressive display of hydraulic power. The entire truck is tilted at a steep angle by a massive platform, causing the 23-ton load of sugarcane to cascade out of the back and onto a vast receiving table or directly onto a conveyor belt. This torrent of sugarcane marks the raw material's official entry into the factory, a one-way trip. From this moment on, the cane will be carried along a complex network of automated conveyor belts, the arteries and veins that connect every stage of this industrial beast. First things first, the cane needs a good cleaning. Coming straight from the field, the billets are inevitably mixed with soil, rocks, sand, and other junk that could wreak havoc on the sensitive milling equipment. To deal with this, the cane gets a powerful wash. It's tumbled through a system that blasts it with high-pressure jets of water, dislodging dirt and allowing heavier materials like rocks to fall through grates. It's a critical, if unglamorous, first step that protects the multi-million-dollar machinery that lies ahead. After its bath, the clean billets continue their journey toward a machine that will get them ready for the most important step of all: juice extraction. This machine is the shredder. A sugarcane stalk, while full of juice, is also incredibly tough and fibrous. The shredder's job is to tear these stalks apart, breaking the hard, water-resistant outer rind and shredding the inside into a coarse, fibrous mat. It does this with a series of rapidly rotating hammers or knives that pulverize the billets, ripping open the plant cells that hold that precious sucrose. This violent preparation doesn't squeeze the juice out itself, but it dramatically increases the surface area of the cane, making it way easier for the next stage to press out every last drop of sweetness. The roar of the shredder fills the air, proof of the brute force it takes to conquer the cane's natural toughness. The shredded cane, now a fluffy, fibrous mass, is spread evenly onto another conveyor, ready to face the heart of the extraction process. Chapter 3. The Great Squeeze. This is where the real work begins. The shredded sugarcane mat is fed into the jaws of the milling tandem. It's a colossal assembly of machinery that's the pinnacle of mechanical pressing technology. A milling tandem isn't just one machine, but a series of 4 to 6 enormous roller mills, all arranged in a line. Each mill consists of massive, grooved cast-iron rollers, some weighing over 30 tons apiece, that spin in opposite directions. The shredded cane is forced through the gap between these rollers, which are set with progressively smaller clearances. The pressure is astronomical, capable of squeezing the cane with a force equivalent to the weight of several locomotives. As the fibrous mat enters the first mill, a river of raw, greenish-brown juice immediately gushes out and is collected in a trough below. The crushed fiber, now noticeably drier, is then guided to the next mill in the series, where it gets squeezed under even greater pressure. This process repeats down the line, with each mill wringing more and more juice from the relentlessly compressed fiber. To get every last bit of sugar, engineers use a clever technique called imbibition. Starting from the second to last mill, hot water is sprayed onto the fibrous blanket right before it enters the rollers. This water dilutes the sugar that's still left in the cane fiber. The juice that comes out of this mill, which is now a bit diluted, isn't sent to the main collection tank. Instead, it's pumped backward and sprayed on the cane entering the previous mill. This smart, counter-current system is incredibly efficient. By the time the fiber exits the final mill, over 95% of the original sucrose has been extracted. The resulting mixed juice is collected from the first couple of mills. It's a complex liquid, containing about 10–15% sucrose, but also a bunch of impurities like dirt and plant waxes that give it its dark color and acidic nature. And what's left behind? A dry, fibrous residue called bagasse. In the old days, this would have been a massive waste problem. But in a modern megafactory, bagasse is like black gold. It's immediately sent on conveyors to the factory's own power plant. Here, it's fed into enormous boilers and burned as a biofuel to produce high-pressure steam. This steam does two things. First, it's used for heating all over the factory, like in the evaporators we'll see in a bit. Second, it drives massive turbines connected to generators to produce electricity. This process, called cogeneration, is so efficient that it not only provides all the power the entire factory needs to run, but it can even generate a surplus of electricity that is sold back to the public grid. The very fiber that protected the sugar is now used to power its transformation. Chapter 4. The Purification Gauntlet. The mixed juice that came from the mills is sweet, but it's a long way from being sugar. It's an opaque, acidic liquid loaded with suspended solids like soil, plant fibers, waxes, and fats. If you just boiled this down, you'd end up with a dark, bitter, and impure mess. To get to the pristine white crystals we all know, the juice has to go through a tough purification process called clarification. This is where brute force gives way to careful chemistry. The process starts by heating the raw juice. Then comes the key ingredient, milk of lime, which is just a suspension of calcium hydroxide in water. The lime is carefully mixed into the hot juice, and its main job is to neutralize the natural acids. As the pH rises, a series of chemical reactions kicks off. The lime reacts with organic acids and other compounds in the juice, causing many of the dissolved impurities to precipitate or turn into solid particles. The lime also acts as a flocculant, causing all the tiny, suspended bits of mud, fiber, and wax to clump together into larger, heavier particles called flocks. With the impurities now clumped into heavy solids, the next job is to separate them from the juice. This happens in a massive piece of equipment called a clarifier, a huge, cylindrical tank, often several stories high, where the treated juice is left to settle for several hours. It's a simple process of gravitational separation. The heavy, flocculated particles sink to the bottom as a thick sludge, where they're collected by slowly rotating rakes. Meanwhile, the clean, light brown, translucent juice rises to the top, where it's skimmed off. But this factory wastes nothing. The sludge from the bottom of the clarifier still has a good amount of sugar in it, so it gets pumped over to large, rotating vacuum filters. A vacuum sucks the remaining sugar juice through a fine mesh screen, leaving the solid mud cake behind. This recovered sweet water is sent back into the process, and the final mud, now rich in minerals, is a valuable byproduct used by farmers as fertilizer for their fields, completing the natural cycle. The clear juice, now free of solids and with a neutral pH, is ready for its next challenge. Chapter 5. The Vanishing Act. The liquid coming out of the clarifiers is clean, but it's still mostly water, only about 10–15% sucrose. To get to the crystallization stage, the factory has to get rid of a massive amount of this water, turning the thin juice into a thick, viscous syrup. Just boiling it in an open pot would use a ton of energy and would probably burn the sugar, causing it to caramelize and darken. The clever solution is to boil the juice under a vacuum. By lowering the pressure, you lower the boiling point of water, which allows for rapid evaporation at much cooler temperatures. This protects the sugar's quality and saves a huge amount of energy. This is all done in a system called a multiple effect evaporator. It's not a single tank, but a series of large, interconnected cylindrical tanks called effects. The genius of this system is how it cascades energy. Steam from the factory's boilers heats the first effect, bringing the juice inside to a boil. The water vapor that boils off the juice in this first tank is then piped over to become the heat source for the second tank, which is held at a slightly lower pressure. The vapor from the second effect then heats the third, and so on, down the line for 4 or 5 effects. Each tank in the series operates at a lower temperature and a higher vacuum than the one before it. Inside each effect, the juice flows through a series of tubes while the heating steam is on the outside. As the juice travels from one tank to the next, it gets progressively thicker and more concentrated. The whole thing is a continuous, highly automated flow. By the time the liquid emerges from the final effect, it's completely transformed. About 80% of the water has simply vanished as vapor. What was once a thin, watery juice is now a thick, golden amber syrup with a consistency like honey. Its sucrose concentration has been cranked up to between 55% and 65%. This thick, supersaturated syrup is the key ingredient for the most magical part of the entire process: the birth of the crystal. Chapter 6. The birth of a crystal and the great separation. We've now arrived at the very heart of the sugar factory, the sugar house, where the real alchemy happens. This is where that liquid syrup is finally transformed into solid crystals. The entire process takes place inside enormous vessels called vacuum pans. They're similar to the evaporators, but they're built for a much more delicate and controlled operation. Inside these pans, the thick syrup is boiled one last time under a high vacuum. A highly skilled operator, known as the pan man, carefully watches the boiling process. As more water evaporates, the syrup becomes supersaturated, meaning it holds more dissolved sugar than it should be able to. It's a highly unstable condition, and the sugar is just waiting for a reason to come out of the solution. At this exact critical moment, the operator seeds the pan by introducing a small, carefully measured amount of microscopic pure sugar crystals. So fine, they're like a powder. This act of seeding is the magic trigger. The trillions of tiny seed crystals provide the perfect landing spots for the excess sugar molecules in the syrup to latch onto. Almost instantly, new crystals begin to form and grow. The pan operator now has to perform a delicate balancing act, carefully controlling the rate of evaporation and adding more syrup at just the right times to feed the growing crystals without creating new, unwanted ones. This goes on for several hours until the entire vessel is filled with a thick, heavy mixture known as masse-cuite, a French term meaning cooked mass. The masse-cuite is a dense slurry of newly formed sugar crystals suspended in the remaining syrup, which is now called molasses, or mother liquor. The masse-cuite is then dropped from the vacuum pan into a holding tank, ready for the great separation. This is the job of the centrifuges. A sugar centrifuge is basically a giant, high-tech washing machine on an incredibly powerful spin cycle. The masse-cuite is fed into a large, perforated metal basket inside the machine. This basket then spins up to incredible speeds, hitting anywhere from 1,000 to 1,800 RPM. The immense centrifugal force pins the masse-cuite against the basket wall. The solid sugar crystals are too big to pass through the screen's tiny holes and are held back. But the liquid molasses is flung outwards with tremendous force, passing through the screen and into an outer casing where it's collected. To give the crystals a final cleaning, they're often sprayed with hot water during the spin cycle to rinse off any remaining film of molasses. After a few minutes, the machine slows down, a gate opens, and what's left is a wall of glistening, pale gold raw sugar crystals. The molasses itself is a valuable byproduct, rich in the sugars and other stuff that didn't crystallize. It's collected in enormous storage tanks and is used in animal feed or fermented to produce ethanol. Chapter 7. The finishing touches. The crystals that come out of the centrifuge are finally recognizable as sugar, but they're not quite ready for your kitchen. They're still damp from the washing process and are all clumped together. The final act in this industrial saga is to dry, cool, grade, and package the finished product. From the centrifuges, the damp sugar is dropped onto conveyors that carry it to the dryers. A common type is a vibrating fluid bed dryer. Here, the crystals are fed onto a perforated bed while hot, clean air is blown up from below. This makes the bed of sugar behave like a fluid, ensuring that every single crystal is surrounded by hot air for fast and uniform drying. The sugar tumbles through the dryer until its moisture content is reduced to an incredibly low level, often less than 0.1%, which is essential for preventing clumps and ensuring a long shelf life. Immediately after drying, the sugar has to be cooled. It's passed through a similar fluid bed cooler, but this time with cool, dehumidified air to bring the crystals back down to room temperature. This is important to prevent moisture from condensing on the warm crystals when they're stored. With the sugar now dry and cool, it goes through its final quality control checks. It's passed over a series of vibrating screens with different mesh sizes, which act like giant sieves, separating the crystals by size to ensure a uniform product. At this point, the path can split. The sugar produced is a high-quality raw sugar, which is ready for many industrial uses. But to make the brilliant white granulated sugar most people expect, it often goes through an additional refining step. This involves remelting the raw sugar into a syrup, putting it through more purification steps like carbon filtration to remove the last traces of color, and then recrystallizing it one last time to get the highest possible purity and whiteness. Finally, the finished sugar is transported to its last stop in the factory, the storage and packaging facility. It's stored in colossal silos, towering structures that can hold tens of thousands of tons of sugar, keeping it safe from humidity and contamination. From these silos, the sugar is fed into highly automated packaging lines. Here, a dizzying array of robotic arms and machines weigh the sugar with incredible precision and pour it into everything from small paper bags for supermarkets to enormous bulk sacks for industrial food producers. The sealed packages are then robotically stacked onto pallets, ready for shipment. What began as a simple plant, a stalk of cane standing tall in a sunlit field, has now completed an epic journey. It's been harvested by giants, shredded, crushed, boiled, purified, crystallized, spun, and dried. It's traveled through miles of conveyors and pipes, transformed by a perfect blend of immense mechanical force and precise chemical control. From the vast fields to the final crystal in your coffee cup, the journey of sugar is a hidden world of industrial marvels, working around the clock to satisfy the world's sweet tooth. If you are fascinated by this look inside one of the world's most impressive industrial processes, be sure to like, comment, and subscribe for more amazing documentaries.